Hello, everyone. This video is going to be your intro for your harmonic motion of a spring lab that you're going to be doing on your own between now and Friday. Um, there's going to be a link provided in Schoology, so it's going to take you to a PhET simulation, and this is the screen that's going to pop up. Make sure that you click the lab, because that's what we're doing, so don't click the intro, vectors, or energy. So we click the lab, and this is what we saw the other day that we played around with. And basically every setting here we can have as an independent variable. So just going through our independent variables, we can put this mass on and change it. When you do change the mass, try and do so significantly. Whether you do 4 or 5 different trials, you'll see in the lab analysis guide that it kind of is already in there for you. But there's not that much of a change of mass between 50 and 300. If it was in person in class, we could put like 1500 on here or 2000, depending upon the spring. So make sure that you vary that. It's also easily seen that we can change our spring constant. So it goes from small to large. Unfortunately, it doesn't have a numerical value there. So you're going to have to calculate that in the first objective. And I'm going to touch on that in a moment of which settings you're going to be assigned. On the right-hand side, we have a ruler, we have a stopwatch. So we only looked at 2 independent variables. There's some more, and we need to determine what our dependent variable is going to be. So another one of the variables that we're going to look at is displacement. So if we have this scenario, and we see where that black line is the center of that mass. We also have this movable line, which is going to be our friend. So I'm going to put that right at the bottom there. Maybe. So the movable line is going to be my reference point. So my one trial, I displace this a certain amount. Well, I'm going to have to know how much I displace it. So I pull it down 10 centimeters, make it oscillate, and I measure a dependent variable, which we didn't determine yet. So my next trial, one of the little hints here, or kind of things I've seen over the years, instead of hitting the reset button, you can play around with the damping button. The damping is basically the friction in that spring. So if I move it to lots, everything stops, move it back to none, and then I could continue on with my trial. So the first time I moved it down 10 centimeters, now I'm going to move this down 20 centimeters. So the displacement from equilibrium is going to be another independent variable that we're going to look at. And it's a little confusing because you have all of these little reference marks. So the top button on the right, the displacement natural length, that would be if there was no mass attached. So this is going to become important for determining your spring constant. So if we have a spring and we stretch it out with some known weight, well, we don't have a weight or a force, but if you know the mass, you know the weight, therefore you know the force that's used to stretch it out. So that's going to be used for that objective one to determine your spring constant. For the rest of the lab, you really don't need to look at your displacement little tab there, button, but I tend to use my movable line. So if I want to have that exact position and I stretch it down either 10, 20, or 30 or 40 centimeters, that's what, it's easily seen there. So far we have our changing mass independent variable, our spring constant, and then our displacement or our amplitude, right? How far it's displaced from rest. We're not going to mess around with gravity. Damping, that's just friction, so we know that's going to, make things stop and create thermal energy. So what's our dependent variable going to be? Our dependent variable is going to be time, or better yet, period of oscillation. A period is the time for one thing to occur. So in this case, an oscillation, a complete cycle, if you will. So if I pull this down to say 30 centimeters and I let it go, it's going to go up and then come back down to that 30 centimeter mark if it's still attached. So that will be one complete cycle. They do have this period trace button on here. So it starts it at equilibrium, right, that black dot, and you can see that it traces its path all the way up, all the way back down, into that equilibrium position, if it was like, say, here. Feel free to use that. I think the easiest thing to do, that we've seen in other classes, is turn on your slow motion, and displace this, whatever distance, whether it's going to be a constant or a changing variable, and then use the stopwatch. So I'm going to do it when it comes back down, or I'm sorry, I'm going to move this down to here. Right, so I know I started at 20. So when it comes back down to 20, I'm going to start it. And then when it returns to that initial red line, I'm going to stop it. So that's my period of oscillation. So I know for one complete cycle for this setting, it's about 0.77 seconds. So I'm going to jump over to our lab guide, which is here. And you can see that it gives you, it's all structured. So the first thing we're going to need to do, which isn't necessarily part of the experiment, is determine the spring constant. So later on in the lab, you're going to be changing the spring constant. So you'll have 1, 2, 3, 4 different springs. We're not going to have colors. That was for like in person. But we're going to have a number, and I'll show you what the numbers mean. So you can pick 1, 2, 3, 4, 1, 5, 7, and 9. You're going to be assigned one. And so that you don't have to go through and calculate 4 different K values or spring constants, we're going to spread up the work. So for objective 1, I'm going to ask you guys that you do that either tonight or some point tomorrow and post it to Schoology. So on that slider bar at the top of the simulation, there's no numbers, right? It's just those little markings. So we're going to go by this guide and say like spring constant, number 1, 2, 3, 4, all the way to 10. So to spread this out a little bit, if your last name begins with a certain letter, that's the number spring constant that you're going to do, right? So my last name is Ford, so I would make sure that I have this on setting 4. So I'm probably going to use that setting as a constant. So when I do my lab, I'll do spring number 4, and then as I'm going through my lab, my other constants would obviously be my K value, whatever number 4 would be. Which is a good point. When you go through the different experiments, make sure you identify the constant and its value. So when I'm changing my amplitude for objective 2, this is the displacement from rest. Whatever my mass setting is, I don't know what it would be, or it wouldn't be kilograms, it'd be grams. Make sure you give that value. And again, in all of these, our dependent variable is going to be the period, which is just time for a complete oscillation. So like we said, objective 1 is just getting that initial spring constant so that for objective 4, you can easily vary it, just change it, and your classmates will give you those values. So we're going to change the amplitude like we mentioned, measure the period, change the mass, measure the period, and then the last one that we mentioned. You may notice for objectives 3 and 4, there's 2 graphs. The little hint there is that you might have to linearize a graph. So if this is going to be period, which the symbol for period is T, maybe we're going to get a curve. Maybe look back at some prior labs or some, I guess this is algebra, of how to linearize that curve. What are you going to have to do? Are you going to have to square a certain axis, take a square root, do an inverse, depending upon what the data shows you. And if you can, make a relationship. Are they inversely proportional? Are they directly proportional? Is, one changing as a square root as the other one? Again, I'm not going to have you guys officially submit this. I just want you guys to make sure it's done, because you will not get class time on Friday to do the whole lab. On Friday, we'll just kind of touch on some things. You'll make some quick fixes and then submit it within like 10-15 minutes. But if you don't do it in advance, you're not going to have that time to submit it on time in class. Between now and Friday, if you do have any questions like about settings or anything, make sure that you reach out to me. I'm going to go back and kind of look at a couple things here too. You don't really need to use the velocity or acceleration. Like I said, be careful with your reference points. They have all these different lines. I will let you know that for objective 1, to find that spring constant, the easiest thing to do, hang your mass, turn on damping so it goes there, and just measure your displacement. So we have our displacement, and our displacement's you can measure that actual green vector, because we're going from, there's no little arrow, but that little kind of connection point on the spring. So when this is off, the spring is there. When this is on, oops, I changed that, but measure that distance. But when you are going and conducting the lab, I know that's wrong, don't worry about it. You probably want to use the movable line, so that as a reference, I'm going to pull this down to 10 centimeters, collect my data that I need. Maybe this next one, my displacement is going to be 20, pull it down to here, so that you have that reference. And again, reach out if you have any questions.